Intracranial pressure. Definition: as is the pressure inside the cranial cavity and is the result of the interaction between the contents, tissue, and contents, brain, cerebrospinal fluid, and blood. Application in nursing: checking vital signs orally, assess the state of continuation of the patient, administers prescription medication and monitor, control water balance. Pros and cons: mental impairment, vomiting, cardiovascular disorders. With stigma and treatment, the patient has the better chance of recovery without square. Used application in equity. Patients with intracranial pressure are mostly from preventable accidents. By degree in injury is the treatment and posterior rehabilitation.
Alright, I want to talk a little bit about intracranial pressure and what happens when it increases. So some terms that you should be familiar with are cerebral blood flow, which is the amount of blood delivered to the brain. And a key thing about cerebral blood flow is that brain perfusion depends on maintaining that cerebral blood flow. Another term you should be familiar with is cerebral perfusion pressure, or CPP. That is the pressure that keeps blood moving throughout the brain. Now there's an equation for cerebral perfusion pressure, and that's MAP, or mean arterial pressure, minus ICP, or intracranial pressure. So cerebral perfusion pressure is equal to MAP minus ICP. We'll come back to that later. Another thing you should know is that the intracranial contents, or the stuff that's in a normal ICP, is 10 to 15 millimeters of mercury, and we're going to talk about what happens when that increases. So this red spot here is meant to simulate some sort of injury to the brain. As bleeding occurs, brain and blood vessels are compressed, as well as cerebral spinal fluid. This restriction in blood flow causes ischemia, and swelling of brain tissue causes more ischemia. So you get this nasty cycle of ischemia, edema, until brain cells die. So let's look at the bigger picture of what's happening here as well. When we increase our intracranial pressure, we see a decrease in cerebral perfusion pressure. So remember, as we increase intracranial pressure, we are decreasing that pressure that keeps blood moving throughout the brain. That's a bad thing. As we increase our intracranial pressure, we also decrease our cerebral blood flow. Remember, that's the amount of blood that's being delivered to the brain. So as ICP increases, we're decreasing the amount of blood to the brain, and that's not a bad thing. In combination with a decrease in cerebral perfusion pressure and cerebral blood flow, we get an increase in ischemia. As that occurs, we also see an increase in edema and tissue pressure. And then the cycle continues as we increase intracranial pressure more, and that starts the cycle again and again. Think of it this way. As intracranial pressure increases and approaches mean arterial pressure, the cerebral blood flow decreases, which results in a decreased cerebral perfusion pressure. As cerebral perfusion pressure decreases, the body compensates in an attempt to increase blood volume and raise cerebral blood flow. This results in increased ICP, and the cycle continues.
Conclusion: the increased intracranial pressure is lethal if not treated properly and in the time and with proper medication. Patient recovered satisfactorily and very fit and left with sclep.